Okay, geometry students, in this video we will be studying special segments that are within a triangle, okay? We will be looking at their definitions and their characteristics, okay? So your heading for today is segments in a triangle, and the lesson number is lesson 5.2, okay? Segments in a triangle, and the lesson number is 5.2. Segments in a triangle, lesson 5.2, and be sure and include today's date, okay? Today's date. All right, continuing on, here we go. Now, here are the names of the segments that we will be studying today. You do not need to write these down, okay? You do not need to write these down. Just look up here, and we'll quickly go over what we're going to look at today. We are going to study today a perpendicular bisector of a triangle, okay? Now, I know you guys already know what a perpendicular bisector is. Here's a segment. Here's the midpoint right here. And here's a perpendicular bisector. It's perpendicular, and it goes through and it divides the segment into two equal pieces, or two equal segments. Okay, and I know that you know that, but we're talking about the perpendicular bisector of a triangle. We're going to look at the angle bisector of a triangle. We're also going to look at the median of a triangle. We're also going to look at the sorry students, the altitude of a triangle. So once again, students, you do not need to write these down. We'll go over them later, but here are the four segments that we're going to look at today. Okay? All right, moving on, here we go. Let's start off first by looking at a perpendicular bisector, okay? A perpendicular bisector. Okay, copy this definition in your notes, students. You are responsible for this definition, so please copy this in your notes. Okay, copy this down, please. Perpendicular bisector of a triangle. It is a segment that lies inside the triangle and is a perpendicular bisector of one of the sides. Okay, perpendicular bisector of a triangle. It is a segment that lies inside the triangle and is a perpendicular bisector of one of the sides. Now, like usual, guys, I'm going to give you a picture of this. So here we go. Copy this in your notes, please. You definitely need to copy this in your notes, okay? Because we're going to do something extra, not extra special, but, well, we're going to do something here you need to pay attention to, okay? So here we go. Copy this triangle in your notes if you would, please. And let's call this triangle A, B, C. Alright, there we go. I'll give you guys a second to get caught up. I know I'm going a little fast here. Copy that down, please. Okay, so almost forgiving you time. Here we go. Now, let's go ahead. Let me show you what a perpendicular bisector looks like, okay? Now watch this carefully. Okay, we're going to go right here to the midpoint. I'm going to put a point right here, okay? So go to the midpoint. And then we're going to draw a line that is perpendicular to this line. So there we go. That line right there is a perpendicular bisector of a triangle. How do I know that? Well, let me show you. Watch. It's right. The point right here is right in the middle, and it's 90 degrees right here. So there we go. Now let's draw another perpendicular bisector, okay? So let's go to this side here and find the midpoint right here. And then we're going to draw a line that is perpendicular, okay, to this line here. So students, here's the midpoint right here. I'm going to draw a line that's perpendicular, okay? So here we go. And there's another perpendicular bisector, okay? Right here. Now let's go ahead and draw the third and last perpendicular bisector, okay? So let's go to the midpoint of this side over here and draw the perpendicular bisector, okay? So here we go. And actually that point should be a little more down here. Okay, let's draw a perpendicular line here. Okay, there we go. Now, does everybody see what we've done? Let's not go any further until you understand this. A perpendicular bisector of a triangle is a segment that lies inside the triangle and is a perpendicular bisector of one of the sides. Okay? Now, let's do something else. Look what happens if you draw the segments. Keep them going until they intersect. Watch what happens. So in your notes, go ahead and keep extending your segments until they intersect. Now theoretically, they should intersect in one point. If they don't, then kind of bend your lines, okay? Kind of cheat a little bit, because they should always intersect in one point, okay? So go ahead and do that, please. Very important that you do this, guys, okay? Everybody see that? Everybody got it? Now write this down. And I did not want that, so hold on one second, guys. Hold on one second. Now make note of this in your notes, students. Write this down, please. Look. Circumcenter. Okay? Write that down, please. You must know this. Students, you're responsible for this term, okay, on a test or a quiz. Circumcenter, the point where all three perpendicular bisectors intersect. So this point right here, this black point, is called the circumcenter. And you need to know that, okay? So quickly copy this down. The point where all three perpendicular bisectors intersect. Now, having said that, look at this next note. Please copy this down. You need to know this, okay? Here it is. The circumcenter is equidistant from the vertices of the triangle. So what that means is this. From this point to C, and from this black point to A, and from this black point to B, those three green lines are all the what? Make note of this in your notes, guys. You need to know this. I would draw these lines so you can see them. Those green lines are the same length. Okay, so if I know this is a length of 5, then I know this is a length of 5 also, and I know this also is a length of 5. Okay, so there we go. The circumcenter is equidistant from the vertices of the triangle. Okay. I'm just going to pause for a second and make sure you guys are all caught up. It's really important that you understand all this information, okay? All right, let's continue on. Here we go. All right, next we're going to look at the angle bisector of a triangle, okay? The angle bisector of a triangle. Now here's the definition, so please copy this down. The angle bisector of a triangle. A segment that lies inside the triangle and bisects one of the vertices. Okay, a segment that lies inside the triangle and bisects one of the vertices. Okay, I'll give you a second to copy that down. A segment that lies inside the triangle and bisects one of the vertices. Angle bisector of a triangle. A segment that lies inside the triangle and bisects one of the vertices. Okay? Now, here's what it looks like. So please take some really good notes, okay, guys? Here's what it looks like. Copy this down. take some good notes and try to draw your angle bisectors accurately so that you can see where they intersect later, okay? So I'm going to draw an angle bisector right here at A, okay? So here we go. I'm going to cut this angle in half the best that I can, okay? And we know with Mr. Yar's drawing skill, it's not going to be that good, but we'll do the best we can do here. Okay, so there we go. There's an angle bisector. So this angle here should be congruent to this angle right here, okay? So there's a picture of what an angle bisector of a triangle looks like. Now go ahead and draw that. Draw the rest of them on your own carefully, okay? So here's my next angle bisector. I'm going to cut this angle right in half, okay, the best that I can. Okay? And again, I'm laughing because theoretically, your angle bisectors should all intersect at one point. So if they're not, kind of cheat like I am and make sure they do, okay? Because they will intersect at one point. I'm not sure what I did there, but here we go. Okay. So there we go, okay? So an angle bisector is a segment that bisects a vertex of a triangle. Remember, a vertex is this angle right here. Okay, these are called the vertices, plural form, of a triangle. So this point right here, where all three angle bisectors intersect, does have a name, okay? This point here does have a name. I'll give you guys a couple more seconds to get caught up here, okay? Make sure you have this definition written down, and make sure that you have this triangle drawn here with these three angle bisectors. Okay, moving on now. This point, the students, this point right here, this black point is called the incenter, okay? the incenter. And it's the point where all three angle bisectors intersect. And you do need to know this for tests and quizzes, okay? So write that in your notes, please. Okay, copy that down. The incenter, the point where all three angle bisectors intersect. So this point right here is called the incenter. Now, there is something special about that point, and here it is. So please take some really good notes on this. The incenter is equidistant from the three sides of the triangle. So, take some really good notes on this, guys. Watch this. Remember, when we say a point is equidistant from a line, we're talking about the perpendicular line. So, from this point, I'm going to draw a line from here to this side here, so that's perpendicular, okay? And then I'm going to draw a line from this point to this side over here, so that's perpendicular. Okay, so there we go. And then I'm going to draw a line from this side here, so that's perpendicular to that point. When you do that, those three green segments are the same length, okay? These three green segments are the same length. So please make note of that in your notes. You need to know that, guys, okay? The incenter is equidistant from the three sides of the triangle. Okay, so if I know this length right here is 4, then all of these green lengths here are 4. Now somehow please take some really good notes in your notes on this, okay? Take some really good notes on all of this. Make sure you're writing all of this down. because you're definitely responsible for this information. I'll give you a couple more seconds to write this down. Okay, students, let's continue on now. Only two more to go. The next one will be the median, okay? The median of a triangle. So, here's the definition. You're responsible for this, so please copy this down. The median of a triangle is a segment whose endpoints lie on the vertex and the midpoint of the opposite side. Okay, so a median is a segment whose endpoints lie on the vertex, that's one end of the segment, and on the midpoint of the opposite side. Okay? So go ahead and take a second and copy that down in your notes, please. And then I'll give you a picture of it. A segment whose endpoints lie on the vertex and on the midpoint of the opposite side. A segment whose endpoints lie on the vertex and the midpoint of the opposite side. Okay, so with that in mind, here's a picture of what it looks like. Okay, copy this down, please, in your notes. Okay, here's your triangle. Now, students, watch carefully how I draw a median, okay? Please take some really good notes. I'll pause a second while you quickly finish your triangle here. And then we'll look at how to draw a median, okay? So here we go. Okay, now, first of all, come over here and find the midpoint, okay, about right here. And then draw a line from the midpoint to the vertex. And there's your median, okay? Okay, got it? Now let's find the midpoint over here. And we're going to draw a line from the vertex to the midpoint. And that's another median. And now, guys, you're seeing why today we're doing notes only, okay? This is a lot of information that you have to memorize, okay? A lot. Okay, then lastly, we'll go to the midpoint over here. And we're going to draw a point from the midpoint right here over to this vertex. Now, technically, once again, like the other two segments, they should intersect in one point. If they're not, kind of make it so they do, okay? So there's your three median, students. And here's the point where they all intersect right here. Okay, so I'll pause a second while you guys get caught up in case you're behind a little bit. But once again, a median runs from the midpoint to the vertex like this, or from the vertex over to the median right here. Okay, so here's what the three medians would look like. Now, please make note of this in your notes, students. Copy this down. This point right here, students, this black point is called the centroid. Okay, the centroid. So write that in your notes. You're responsible for this definition. And it's called the point where all three medians intersect, okay? The centroid is the point where all three medians intersect. Okay, now there's something special about this point, just like there were in the other two, okay? And I'll put that up here on the screen in just a second. Go ahead and copy this down. The centroid is the point where all three medians intersect. The point where all three medians intersect. Okay, now, notice, students, that the centroid is 2/3 of the distance of the median from the vertex. Now that should really sound confusing, but first of all, go ahead and copy this down. and then I will explain that very well up here, okay? So copy this down. The centroid is 2/3 of the distance of the median from the vertex. I'll show you what that means in just a second here, okay? Go ahead and copy this down. I will show you what it means in a second here, okay? I will explain that very well, okay? Okay, here we go. Call this point here in your notes. Call this point point D, okay? Now, we have median AD, okay? Very easy. Come off to the side here in your notes and write this down. Let's call this point here E, okay? So the centroid here is called E. So make note of that in your notes. Now here's what this means right here. Watch this carefully, okay? Take some really good notes. It means this. Let's pretend that AD has a length of 12, okay? 12. Well, what that means then is segment AE is 6, 8, and segment ED is 4. 8, 4. Okay, so the longer, do you see how AD is divided up into a longer segment here until you get this point here, and then a shorter segment here? The longer segment will always be twice as big as the segment, okay? And students, this longer segment here will always be 2/3 of the entire segment. So let me show you the best way to do this, okay? If the entire length is 12, always take your total length of your median and divide it by what? 3. Always divide it by 3. That will give you the length of the shorter segment, okay? It's that easy. And then the longer segment is always twice as big as the shorter segment. Okay, so not too difficult. So if I were to tell you this length here was, let's pretend I told you this length here was 8, and I asked you to find this length here, you would know right away this length here would be 16. And if I asked you to find the entire length, it would be 24. 16 plus 8. If I told you this length right here was 18, and I asked you to find this length here, well, it would be 9, half as big, okay? And then the whole length would be 27. So look that over, guys, make sure you understand that, okay? But that is what we know about this point here. And this point here where all three medians intersect is called the centroid, okay? The centroid. And it's 2/3 of the entire distance of the median from the vertex. Okay? Alright, moving on to finally our last special segment, and it's called the altitude of a triangle, okay? The altitude of a triangle. Go ahead and copy this in your notes, students. Here's the definition you need to know. Altitude. A segment running from the vertex perpendicular to the opposite side. Okay, a segment running from the vertex perpendicular to the opposite side. Now this next sentence, students, is really important. An altitude may lie inside or outside the triangle. You need to know that, okay? An altitude may lie inside or outside the triangle. Now you're responsible for this whole definition for fill in the blanks later, okay? So copy this whole thing down. An altitude is a segment running from the vertex perpendicular to the opposite side. An altitude may lie inside or outside the triangle. Okay, copy that down, please. Now, here's what it looks like. So take some really good notes, please. Now notice, students, I'm going to draw my triangle a little differently this time, okay? So please draw your triangle the way I am. It's very important that you do this. Very important that you do this, okay? I want to show you that sometimes altitudes lie outside of the triangle, okay? So copy your triangle down like this, and we'll call this A, B, and C, okay? Okay, students, let's go ahead and draw an altitude, okay? Now, first of all, it runs from the vertex perpendicular to the opposite side, so I've got to find a point here that comes from this side. It is perpendicular to this line and goes to B over here, okay? So here we go. I'm going to start from B. I'm going to do the best I can. It's not easy to do, but I'm going to do the best I can. Draw a line that's perpendicular to this side over here. Okay, there we go. Now from A right here, we're going to draw a line that's perpendicular to the side over here. But look, it's not possible, guys. Look. I don't care what line you draw from A to this side over here. It will not be perpendicular to BC. So here's what you have to do. You have to extend this side here a little bit, side BC, like this, and then draw the altitude here. So in this case, the altitude lies outside of the triangle, which we said in the definition up here that sometimes altitudes will lie inside or outside the triangle. So here we go. There. Now we have one more altitude to draw. Now students, understand it's going to be really difficult to draw the altitude from vertex C because I have the same problem that I had like I did drawing the altitude from vertex A. Okay, there's no way that I can draw an altitude from C going to the side over here so that it's perpendicular to AB. It's just not going to happen. So here's what I have to do. Once again, I have to extend the side here like this. I'm extending side AB like this so that I can draw a line from this point here to this line here so that's perpendicular, okay? So here it is. The altitude would look something like this. Not the best, but it will have to do, okay? Now guys, listen to me carefully. Technically, all three of these, I'm trying not to laugh, all three of these altitudes are supposed to intersect at one point, okay? I don't think mine's going to do very well, but I'll give it a shot, okay? So here we go. Extend this line here. Extend this line here. I'll have to bend this line here just a little bit to make it work, okay? But technically, if you extend your altitudes, they are supposed to intersect in one place, okay? Now there is a name for that point right there. Let me get some room here real quick here. Let me go ahead and color that point black so we have record of it, so we know which point we're talking about. There we go. Now this point here, this black point here is called the orthocenter, okay? So make note of that in your notes. You do need to know that, okay? It's called the orthocenter, and it's the point where all three, and this is wrong right here, all three altitudes intersect, okay? It's the point where all three altitudes intersect. Now, there is, just so you know, let me just wait a second here while you're copying that down. Orthocenter, the point where all three altitudes intersect. The point where all three altitudes intersect. Now, just so you understand something, students, there are some special things about the orthocenter. We will not get into it this time. I think one of the things I remember from my earlier studies, there's a line called the Euler line. Okay, and if you find the what's it called? Not the. I think it's this point here, the orthocenter and the centroid. And there's another word I'm trying to think of we've not covered yet. But anyways, whatever that word is, I'll put a question mark. All three of those points would line up in a straight line, and they call that straight line the Euler line. Okay, we're not going to learn that in this class. It's not in the book, so I'm not worried about it. But the other three segments that you've learned did have some special things that you need to know. The orthocenter does not, except you need to know this, the point where all three medians intersect. Okay, you do need to know that. Okay? All right, I hope this has made sense today. One more quick note. In closing, I want to give you one more term. Did you notice how all the segments we kept drawing always intersected at one point? Or at least they were supposed to, okay? With some of my drawings, that wasn't always the case, but there's a name for this, and you're responsible for this term. So copy this in your notes, please. You need to know this. We're going to use this term throughout the year, so you need to know what it means. When lines intersect at one point, we say the lines are concurrent. You need to know that, okay? That would make a great fill in the blank on a test or a quiz. When lines intersect at one point, we say that the lines are concurrent. And you need to know that, okay? Guys, I've given you a lot of notes today. I hope you've taken really good notes. You're responsible for all these terms. Please continue to work hard in class. If you have any questions, don't hesitate to call or email.